In this final section, we're going to look at colloids and suspensions. And it turns out that the difference between solutions, colloids, and suspensions is essentially particle size. So if we look at a solution, okay, where these things are dissolved, we end up with a homogeneous mixture where the particles are dissolved and they're relatively small. In a colloid, the particles remain dispersed, but they're much larger. They won't actually settle like in milk, okay? It won't actually settle out, but they are not dissolved in the same way as in a homogeneous solution. And then if you look at a suspension, like mud, these particles will settle out. Now, if you want to settle out faster, okay, for example, you could put them in a centrifuge. But if you were to take muddy water and let it sit for a while, the mud particles, the dirt particles, would settle out slowly because they are much larger. So they do not stay dispersed within the solution. So again, in a solution, it's a homogeneous mixture where the particles are actually dissolved. A colloid is somewhere in between where the particles are larger, so they won't actually settle out of solution, but they're not actually dissolved either. And in a suspension, the particles are very large and they will settle out. One interesting thing you can do is the Tyndall effect, which is if you shine a flashlight at a liquid that you are not sure if it's a solution or a colloid, okay, if you don't see any light in the solution, it's a solution. If you see the beams of light, which they're representing here by you can actually see where the flashlight is going through versus here you can't see where the flashlight is going through, then you know that it's a colloid. How do you know that? Because the light is actually bouncing off these particles of solution, the particles in the colloid, which is how you actually know that there are particles there, because those particles deflect the light back and you can see that light, which is why you would see the flashlight beam flow through it. This is something when I was in graduate school we would have to do on a regular basis because we weren't sure if we had a solution or a colloid, so you just shine a light at it and that would allow you to very easily tell if your solute had dissolved into solution. The last thing we want to look at here is how soap works. So we talked earlier about how like dissolves like, but it turns out that grease is oily and non-polar. So how can we get grease to dissolve in water? Well, it turns out we use these molecules that have both properties, okay? We have this huge non-polar, which they call hydrocarbon chain, or this non-polar tail. And we have this ionic head. So this part is attracted to grease because it's non-polar. This part is attracted to water because it's ionic. So this is sodium stearate, which is found in soap, and this is sodium lauryl sulfate, which is the same idea. The ionic part is different and the length of the chain is different, but it's the same idea where you have an ionic head and a nonpolar tail. And this is used in detergent. So these are two types of soap molecules. So when these interact with a grease particle, what happens is the non-polar tails dissolve into the grease particle and it leaves these ionic heads on the outside, and this is called a micelle. And this forms a colloid in water and it allows these things to be washed down the drain. Something similar can happen if you have bacteria, where the nonpolar part is attracted to the cell wall of the bacteria, and it makes these ionic heads and allows the bacteria also to be washed down the drain. So that's basically how that works. If you have an oil spill, they can take similar types of molecules, which are polar on one end and more nonpolar on another end, and hopefully these can work as a dispersant for these molecules to help break up this oil slick and make it more soluble in water, and again to form a colloid. So these are some practical applications of how to use molecules that are both polar and non-polar to do practical jobs like cleaning things, okay, soaps and detergents, or to break up oil slicks in the unfortunate event that there is some type of oil spill. So that brings us to the end of this chapter.